Hello again. In this video, we're going to continue with section 1.2, or an exercise 1. And it says, suppose that you can eat a meal at a restaurant that costs M dollars, which includes the tax, but not the tip, and you want to leave a 20% tip. Can you write a formula for a function, t of m, that gives you the total you pay, including m and the tip? Don't forget that t of m gives you the total, and m is the cost of the meal. Did you get the answer? Pause it if you did not. Here it is. What is t of m? So t of m is going to be the amount that you pay. So I'm going to say m here, and I'm going to add that the tip. So on top here, I'm going to say that the meal plus the tip is the total, just to help us out. So t of m is the total, m is the meal. How much is the tip? Well, we know that's a 20% tip. So again, 20% is the same as 20 over 100, which is the same as 0.20. If you do it in your calculator, move this over, or you can just call it 0.2. Times the meal. So for instance, if your meal was $100, you take 20% times $100. So we're going to take 20% times m. And I don't need to put anything in because we know it's multiplication. There it is. That is the formula. Or if you'd rather simplify it, you can combine like terms here because there's imaginary 1. So that'd be 1.2m. Let's check your answer and see if it seems reasonable with $10. So let's do t of 10 here and see if it seems reasonable. If you multiply that on your calculator, you get 12, moving the decimal one place. So $12. Now that is not the tip, that's a total meal, because that's what this one was. And that does seem reasonable. The meal is $10, right? That means the tip would be $2, and the total bill would be 12. If you put in the 10 here, you can see all those steps I did. 10 plus the 2 is the 12. This is a nice, fancy way of figuring out your tip, right? You just add a 1 to it, and it gives you the total bill instead of just the tip. So if you take 0.2 times 10 is the tip. Otherwise, you do 1.2. We can see now it's the total bill. What's t of 50? If you did not get the answer before, this might be a good time to pause. But here's the answer. The answer is 60. If you put 1.2 into this and you multiply it on a calculator, you get 60. If you decide to put it in here, you get 50 plus 10, which is also 60. So the answer is $60. Here we didn't put the dollar sign. $12. Exercise 2. Determine if the pair of expressions are equivalent to each other. Verify by either plugging in specific values for x or by graphing each on your calculator or phone with a program called Desmos. You can do that if you want. Go ahead and try this. See which ones you think are the same, are equivalent. Okay, here's the answer. Believe it or not, no, and yes. There they are. Let's try plugging in and seeing which ones are true that way. So you just, to plug in the first way, you just pick, So this is like just a check. Just pick a value. I'm going to pick X is, I like 4, so it comes in perfect. But you could do anything and just use your calculator. The reason I chose 4 is because if I plug in a 4 into the left side, I get 9 plus 16, which is 25, which happens to be perfect. And then if I plug in 4 on the right side, you get 7, and you can see that they're not the same. You can also graph this on the calculator, putting this in y1 and putting this in y2, and you could see that it would not be the same graph. We learned this before, that we saw this example before, that you cannot use distributive property with square roots. You can only use the distributive property when you have a number in front. So that's why that one doesn't work. Whenever you have a bar, there's an imaginary parentheses here. So you cannot say 3 plus 4. You have to add them first. It makes a difference. This one we can clearly see is no, because you distribute, you need that to be a -2. But if I just choose my x equals 4, if I do a little check on this one, -4 plus 2 is the left. -4 plus 2 is the right, and they are different. They're not the same. This one, the answer is yes, because if you FOIL this out, you will get this, right? So you do see it works, but if you verify, let's do a check, verify this is correct, we'll just say since. You can plug in your 4, for instance. Kind of weird one to plug in because this one comes out 0, but you could plug in really anything just to see if the left is equal to the right. And you get 0 on the left. Let's see if we really get 0 on the right. So that would be 4 squared minus 8 times 4. Plug in a 4 on the right. You would get 16 minus 32 plus 16. -6, that is indeed 0. So it does work. So let's continue on the next page. Practicing figuring out where expression increases, decreases, or does not change. Put down your answers, make a guess, and then come back when you're ready. Okay, here's the answers. Suppose A is a constant. That's the first thing you need to know. So A is not changing. So we're having a function with respect to x only. Say whether the value of the expression increases, decreases, or does not change as x starts at 1 and increases. So as x gets bigger. So if we take a number, we subtract 1 and then subtract 2 and subtract 3. What do you think? The answer is decreases. We have x on the numerator. X is 1, x is 2, x is 3. Before, when x was in the denominator, it decreases. But if x is in the numerator, say A is 1, right? X is 1, x is 2, x is 3. It is increasing because the A is staying the same. Now, if A was changing, it'd be the other way around. So this one actually increases. And believe it or not, this one does not change. Why doesn't it change? Because you can cancel since. The x's cancel. You can cancel those and just get A. So it's going to stay a constant. I'll just add the explanations that I just said. This one increases since the x is in the numerator. This one decreases since the x is being subtracted. The next exercise, and again, you can do all of these at once and come back and just check your answers, or you can hear the steps. So write an expression for the sequence of operations. The first one is done as an example. So if we're going to add 3 to x, so that's what they did here. They added 3 to x. I'll redo it. So 3, I'll just say or, because I'll do it a little different way. 3 added to x, and then we double the result. So you take the whole thing and you multiply by 2. Addition is commutative, so they did x plus 3 instead of 3 plus x. They put 2 on the right, and I put 2 on the left. So that part doesn't matter. Multiplication and addition is commutative, but that's how they got the answer. So try B and C. These are all good for practicing word problems. Writing down the algebra of what is read, right, or a function from the words. Okay, did you get the answer? We're going to square x first and then multiply the result by 3. You can put the 3 on the left, right, but I like to put it on the left. So that is one answer. If you want to put it on the right side, that would work too. But you just square the x. You're doing that first. We're part C. It says multiply by 3. So now we're going to multiply by 3 first. And again, I like to put the 3 on the right, but you can put it on the left. Sorry, I like to put it on the left, but you can put it on the right. And then square the result. So we're going to square the whole thing. So we have to put in parentheses. If you just put a square there, it'll look like this one, and it'll look like just the x's squared. Because you remember, order of operations says exponents come first. So if you knew what x was, we'd only square the x. So this one actually you can simplify to 9x squared if you want. Last one. Consider the function, all the different ways of representing these functions. Does this function have a minimum or maximum output? If so, what is the value of that minimum or maximum? So we've talked about this kind before, a little tricky. We're going to have a different way of doing it in the future, but they just want you to use logic here. What is the largest or smallest number? Is it a min or a max? You can use your calculator to help you if you want to try graphing this on a calculator. It's a little challenging, so you might want to try that. But see if you can figure out the answer before you do your calculator. And then pause it. Please come back for an answer. Believe it or not, it has a minimum. What is the answer? The minimum value is 4. How did I get 4? Because here we're adding, that's why it's a minimum. And no matter what, I'm going to add something that is positive. So it's just going to get bigger and bigger and bigger. So what makes 4? If so, what values of t that minimizes f of t? So t equals 3 gets you that 4, right? Minimized f of t. So if you plug in a 3, for instance, you would get that 4. Or you could just say it like this. F of 3, if you plug in a 3, is 4. We can maybe say cents. If you want to graph this, to check it that way, graph the function on your calculator to check your answer. Okay, let's try that. So what I'm going to do, what is the steps again? I'm just going to do the calculator. Step 1, we'd like to go to y equals, and you type in your function. Again, every time there's an x, you type in this key, and then you're going to go zoom standard. Let's go ahead and try that. So I clicked on y equals, and I typed in my function. When I type in that xt theta, which is on the second upper left row there, it turns into an x. And then we're going to go to zoom on the top row there, and standard. Number 6 is standard, so you could press the 6 or just press enter, or scroll down and press enter. So I'll just do 6. And it will give you your graph. And you can see here, Each tick is 1, so 3, 4 does look like a minimum.